So today I'm here. Thanks everyone for coming. I really appreciate it. We appreciate the time you guys take to listen to what we're doing. And today we're going to talk about infrastructure, and specifically what we've been working on with customers over the last year and a half within their infrastructure to do tiering. And tiering, there's a lot of different names for it. There's archive, there's heterogeneous storage. We're going to cover how we've helped the customer do tiering within their environment, why they're doing tiering, and give you a little details about how you can successfully tier in your environment. By the way, has anybody worked with the tiering function in Hadoop, heterogeneous storage or archive or storage policies or types? Anybody? Have any of you worked with it? It's fairly new in terms of Hadoop itself, but it's actually been in production since 2.6, about 1.5 years, 2 years or so. This capability's been in Hadoop. So storage policies and disk types really make up what is called tiering or heterogeneous storage in Hadoop today. Those are the two main components of it. The storage policy defines what storage you're actually moving the data to. So here's all the different ones. These are all built into Hadoop. You can't change them. This is static, but they are very flexible. They don't have to be a specific storage type. They're tied to the disk type that you see here, RAM disk, SSD. Those are just definitions of the storage itself, but you can assign them to any local file system. So you can really, you have the flexibility to use these disk types in whatever kind of storage that you want or data node that you want. And I'm going to show you an example of that, where archive is just a type of data node that you've configured, a different SKU, in other words. The storage policy is set on the parent directory, and everything underneath it inherits, all directories and files beneath will inherit that particular storage policy. You can override that by setting it just on the file itself. So you can move all the way to file granularity a file to a particular place. Now, one thing I want to mention here is this, that you're not really moving the data in terms of the file system. This is completely transparent to HDFS. HDFS sees that file in the same place it was before. But underneath the covers, it'll move to a file system that has an attribute tied to that disk type that you've defined in your Hadoop environment. So it's very, very transparent as far as where your data lives within Hadoop. Okay, so the first question I asked when a customer said, hey, we want to archive our data in Hadoop and we want to tier it, the first question I asked was, why? Isn't it already commodity storage? I mean, why are you going to tier it? So it's a question that I had right off the bat, and it's something I actually became very passionate about over the last year in working on this project. So it isn't really commodity storage in Hadoop. You tie storage to compute so your jobs don't suffer. And I'll talk about that. So it's not really, even though the disk itself is commodity disk, the data node and the data nodes that comprise your capacity within Hadoop, that is actually fairly expensive when it comes to that type of storage in today's market. And why is that? Well, you have your disk here, and in a typical deployment, you have a kind of a lower disk capacity per compute. That's kind of a best practice in Hadoop. Why? Because it's very good for job scalability, for job performance, and you get pretty consistent results because you're not waiting and queuing up for your jobs when you're doing billions of transactions to Hadoop, right, guys? So that's good. The bad news is it's about 5 to 10 times more expensive per gigabyte because you have so little capacity for every compute and data node that you put into your environment. So this is a fairly, once I understood this from the customer, it made so much sense to me. And then we started to go along the path of, okay, well, how do we solve this, right? We have those functions that I talked about already in Hadoop. You know, they put it there for a reason. So now, you know, we can see the reason. I can get much lower storage per gigabyte, right, if I just pile a bunch of disks on the compute node. But what do I worry about if I'm a Hadoop administrator or a Hadoop developer? I'm worried that my jobs will be inconsistent. If I start plugging in, and it's completely transparent to HDFS, if I start plugging in all these very dense nodes in my environment, I can get kind of inconsistent results. I can start seeing performance degradation in my Hadoop environment, and that's something obviously I don't want to happen, right? So therein lies the rub, you know. I have this capability, but I don't want my jobs to suffer, but I do want to save money on my overall environment, and I want to get more capacity for my data so I can store more data that's readily available in Hadoop for analytics. So the ideal is this, and this is my fancy animation. I swear it's the only fancy animation I did. But I am kind of a PowerPoint. I like PowerPoint. The ideal is this, that I move my hot data to that node where I have lower capacity and more compute, and I move my cold data to that archive layer, right? That's going to give me the best performance. It's actually going to free resources up here, which is going to be better for performance. And it's going to get that cold data over here. Now, the cold data over here can still be processed and processed at a very fast pace as long as you're putting data that's very seldomly accessed there, right? You still have compute resources over there. So it actually would be pretty good as long as the data is fairly, you know, not accessed often. So this is the ideal scenario. Much less per gig on your overall infrastructure, more resources to process jobs on that higher compute, better class of disk storage environment. That's the ideal. That's what we're shooting for as I work through with the customer. This is really what we were trying to do. So, and by the way, we've been working on this project for about 1.5 years. So I knew I had about 20 minutes. I'm going to try to really go quickly through this, but I can give you guys any details that you want as we're socializing afterwards. So I want to utilize this archive storage mechanism, but I don't want performance to suffer. So what do I do to make sure that doesn't happen? The answer is intelligent tiering. And that's kind of where I've kind of invented this pillars of intelligent data archiving for Hadoop. So really, you need all these things in order to make sure that that data that you put in archive is going to be data that is not going to affect the performance of your environment and give you the capacity that you want at the lower price you want. If you just did age, for instance, that is very easy to find out in your environment, right? I can look at all my files and I can just say, all these files move to archive. I can run a little batch job to go ahead and do that, set the policy, and start the mover to go ahead and do it in Hadoop. The problem is, and I put a big caution here, is that if you're just using age and that data is still being accessed, you can hit performance problems and you can get user complaints. I'll give you an example. One customer that we have an installation, have our software installed at, we looked at their data. It was about 7 petabytes of data, logical petabytes. You know, there's replicas, obviously. About 7 petabytes of logical data. Over 2 petabytes was data that they actually accessed for more than 90 days. So this data should never, ever go into archive. This is data that they're constantly accessing all the time. But when you're talking about millions and millions of files in Hadoop, and hundreds of millions, and even billions in some case, and at a true hyperscale environment, this is really hard to find that data, right? So this is all the things that you want to see. You want to see heat. When's the last time I accessed that file? How many times have I accessed that file? That is going to be the most important one, and it is there. That information is in Hadoop. It's just not easy to get. It's not that easy to get, but it is in there. We have metadata in Hadoop that we can extract that gives us that information, and I'll talk about that. We want the size. You know, the last thing we want to do is move our 0-byte files that are laying all over our file system to a different place. What a waste, right? They're already wasting resources on the name node. There's no reason to send a copy command for all these 0 files. By the way, that's something that is a really big one. You know, there are problems to solve. There are 0-byte files laying. One customer we went to, we had 150 million 0-byte files, and they were all just results files from MapReduce jobs over the years that they've had their Hadoop cluster running, and they just left them there, you know. And once we removed those files, the cluster actually booted up 5 hours faster than it did previously to removing those files. It was a huge, huge impact. So size is important not only for that, but you know, if I want to get the biggest bang for my buck when I'm moving data, if I know I'm moving big data files first that haven't been accessed for a long time, I'm going to get those over to the archive faster and take advantage of that storage that I'm buying cheaper in my archive layer. And then the last one I want to talk about is usage. So sometimes this is referred to as the velocity of the data, right? Once I ingest the files, how long am I using that data? How long? Is it 1 day? Well, you'd be surprised how much data is just used for a day and then never touched again. There's quite a bit from what we've seen so far. But obviously there's other cases where there's data access for long periods of times, months, years. So understanding that is also important in planning for how much archive you want. How much of this archive do I really want to implement into my environment? Knowing how the usage patterns of your data or your data velocity goes, that is going to be a very important metric. So really all these together give you kind of the complete picture of utilizing this tiering function that was in Hadoop. Hadoop was great to put this in there. They were really great to put this feature in there. It really helps you, you know, optimize infrastructure and save money, but you really need the data and the metrics to make it effective. And that's really what we've been working on. That's what we've been passionate about. So as we've gone through these exercises with customers, we've actually built a product, a software product that will actually do this. And our approach is this. We only want to work with HDFS. We don't want to install any software on the cluster, and we don't want to require any changes to the cluster. No configuration changes whatsoever. So we just want to extract that metadata information, give you a visualization on how your data is being used in heat reports, in user reports, what users are creating all these small files. You know, what application or user is doing that? So we give you a visualization, and it's kind of funny. One customer refers to this as analytics on the analytics data, right? That's really what we're doing. We're giving you information on how your data is used in the environment, and we're doing that through extracting that metadata information. Now we do that through the existing APIs. Just like name nodes transfer the metadata across name nodes, we can go ahead and copy those files as well through the same mechanisms and same APIs. So nothing for you to do, but give us a server to run the software on. And then once you see these reports and you run your custom queries, say I want to see all the data that hasn't been touched for 120 days, and I want to move that to archive. If you want to run a report that implements that type of rule, we can go ahead and give you a optimization engine that will go ahead and break that into, you know, the first time we ran this at the last customer I installed that, it was 86 million files that were eligible to go to archive. Okay? You don't want to send a job with 86 million files, right? You want to filter by size, application. You want to make sure and ensure that they're in smaller usable batches and keep track of what is moved and what hasn't, right? All that stuff you want to do, and we've built an engine to do that as well because you really need to do it. You really need to automate this at scale. You can't do it manually. But we'll show you the data first ahead of time. Again, the software looks like this. We just communicate with the name nodes. It sits on a virtual machine. You know, we need if you're hyperscale, we'll need a little bit more than 32 gigs of RAM. But you know, in general, 32 gigs of RAM as a rule of thumb gets us all the data and does the processing fast enough on most Hadoop clusters that we've seen out there. We do all the processing there on that virtual machine. Again, no software. Your cluster is pristine. We've been installed in the middle of Christmas in environments because all we're doing is really copying a few metadata files every couple hours. And then we're crunching them and giving you the results. So, my last slide. In general, this is what we're trying to do. We're trying to give you the ability to understand what data should move to archive, help you move it to archive so you can lower the hardware costs and software costs and get the better performance and free the resources that you need to process the data that you now care about, to process the data that you're actively doing analytics on. You know, that is what we're really trying to do. And there's other things you can get from these deep storage insights within Hadoop. You can understand, like I said earlier, with user reports and directory reports, I can understand who's creating all these small files in my environment. What is doing, what application is doing that? What user ID? When you plan for expansion and growth, you'll know, how much of my data am I actually processing? So that data needs to stay on a certain type of data node. And then the data that I'm not using but want there, and I want it available because I might have to come back to it at some point, and I want it still in Hadoop, moving that data to an archive layer. So you'll be able to do all these things with our software. Our software has evolved now to the point where it's about a 15-minute install. It takes us a couple hours for an initial baseline to give you this information. We can go back in time. I was mentioning to the Intel team here, the first time we built this software to do this, it was on a 1 billion transaction Hadoop cluster, and it took us a day, to process a day's information. It took us a day, right, to go through all those transactions and rebuild this shadow of the file system in our environment that we can query. And now we're down to about, we can do about 10 days on that type of environment in one day. So we've really refined the process. We got the metrics. So if anybody's interested in getting a snapshot of their environment and seeing this type of information and storage insights out of it, we'd be happy to stop by and just install the software and let you guys take a look at what your environment looks like today. We'd be happy to do that. So with that, I'll open it up to any questions. Yes?
So I guess, I'm assuming you're moving files then on the back end when somebody has to move it to different storage?
Yeah, so the question is, are we moving the files on the back end when we want to move it to archive, say? And the answer is no, and yes. So Hadoop has the mechanisms built into it to do that. So just like Balancer, if you assign a policy of 4 copies of the data, and you only had 3 before, what does Balancer do? Balancer goes ahead and the name node says, no, I'm supposed to have 4 copies of that file. Go ahead and do that. That's what Balancer's job is, right? Mover is exactly the same for storage policy. So if I say, this storage policy now has archive, the next time Mover is executed, it will go ahead and read that policy and move it. So when we say we will help you automatically optimize, what we do is we actually will change the storage policy on the files that you want to change the storage policy for, and we'll do that in batches. We won't do it all at once. We won't change all 86 million files and change the storage policy. That would be bad. because when mover runs, it's going to try to do everything, just like balancer would, right? So we try to make it in usable batches, and you define the criteria, really. You tell us how much per day or how much per hour or what size files you want to move, or any of that information. Answer your question? Great. And again, I'm sorry, one other data point there, just to emphasize. In Hadoop itself, it doesn't move, right? The file system sees the file exactly in the same place. Even though it's moved to a different storage type, it's exactly in the same place. So it's not like a backup or archive folder in Hadoop. Yeah?
So policies are applied to path prefixes?
Policies are applied to either directories, and then everything at that directory, all subdirectories and files inherit that policy automatically. So when we are looking at what policies you have in place for your data, we actually have to do, this is why it takes us a little bit of time to do the analytics on the data, is we have to recursively go through and apply the policy to all those files from that parent, right? So you can do that, or you can override it even to the file level. I can apply a policy, a storage type, a storage policy to a file. Storage policy in Hadoop is tied to a storage type. You can see here, now that we've kind of, defined what storage policies are, right? You can see here that if I'm doing let's say I'm doing one SSD. I want one copy on SSD. It's going to be one copy of the data file on SSD, two copies on disk if I'm doing 3. If I have 4 replicas, it's going to be 1 and 3, right? So this is how it works. These are how these work together. Archive, which is, I think, this is kind of the use case that's the best right now. For archive, cold is the policy name. So everything is going to go to the archive layer. All copies that you've defined for that file are going to go to archive. Does that make sense?
So if let's say you cited the 90-day window example, if you have a date string in your path, you would have something that on a daily basis finds day 91 and changes the policy for it so it goes to the archive.
Actually, no. We don't need any hints or keys. We actually recreate the file system and all transactions that happen on the file system on our analytics engine. So we're actually doing the analytics already. So we're seeing that that file hasn't been touched for 90 days. We know it because we're reading the file system metadata and all the audit logs and the edits.
You said that one of the criteria for one of the pillars is usage.
Yes.
So isn't there some kind of semantics around understanding, okay, this is no longer used after 90 days, it's right for...
There is definitely. But that information, again, is in our analytics reports. That's one of the analytics reports we do. So we give you a usage report. Once we do analytics, we give you base reports. We give you heat reports. We give you usage reports. We give you replica reports. So how many replicas of data do I have? Surprisingly. When people run out of space sometimes, they'll just move everything to 2 copies just to make space. And then they forget about it. And pretty soon you have a petabyte of data that's sitting on 2 copies, So we give you that, basically all kinds of insights. Users, how users are using the data, what kind of data that they're introducing into Hadoop or ingesting into Hadoop is the proper term. All this information is there as we do our analytics. And we're getting it all from the metadata. We're not going to the file system and walking through the file system. We're not doing any of that. We're getting the FS image file, the audits files, the edits files, and then we're taking those in and we're doing analytics on that.
So if the secondary node is keeping up with all the edits and everything, so all you have is an FS image without the deltas, how are you getting the trajectory for because you want to access frequency and usage, without going to the resource managers, I need to really understand what paths are being accessed. How do you get that?
We get it from the metadata. So let me give you an example of multiple servers in action here, right? Let's say we have an HA configuration. I have my 2 name nodes, and I have my journal nodes. So our software automatically will say, okay, this is an HA configuration. Please tell me the primary name node and the secondary name node. And then from that information, we can get everything we need to know about the cluster, where all the metadata lives, where all the journal nodes are, and we can go ahead and extract that data from there. So if you have the FS image file, you have the edits files, and you have the audits files, you have all the information I talked about here in the pillars. It's just hard, very, very hard to extract. It took us a year and a half to build something that would do it effectively and efficiently. And we have it down to such a level now that we can really, if you say, hey Pete, I just want to see, we want to see if this is going to be useful for us. If you can you come in and just install it, and we can just take a snapshot look at our environment. We can do that in about 15 minutes to half an hour. We have the software running, and then it takes us about 6 hours to do an initial baseline, because again, we have to basically recreate the file system from a metadata perspective on our system that you're giving us. Make sense? Okay. Any other questions? Thanks a lot for your time, guys. I really appreciate it. Thank you.